जय राम जी की।
ऑफलाइन
बोलो सही से क्या सीखे? व्हाट इज जर्मन?
Is Surabhi or Uma Maheshwari there?
yes sir, Uma Maheshwari here.
Uma Maheshwari. Is Dr. Reddy there on the call?
I'm sorry sir, can you come again?
So today's talk is by Dr. Reddy. Is he in the
Okay.
call?
Wait.
Subba Reddy. Dr. Subba Reddy.
No sir.
No?
No.
He was sent the link. Let me see. Oh. Maheshwari,
yes.
he has the wrong link. He is on Zoom.
Okay. All right.
So can you send this link to
I'll
Okay,
share it
yes.
now, sir, with you.
Send it by mail.
Okay.
And then I will send it by.
Okay, sure, sure.
Please announce to the participants there is a little mix-up. It'll take a couple of minutes to sort out.
Okay, okay, sure, sir. I'll inform them.
Hello, can you hear me?
Yeah, yeah.
Okay, so Subbareddy is yet to join, I think, because I sent him a link.
Sir, I am on call with him. Just I'll speak to him. Dr. Subbareddy, the link you have to use is the Teams link which I just now sent. The one you got was Zoom's link, which was for students. This is for faculty. Yeah. Sir, he got the Zoom link, which was for students. So I just sent.
But
him
I used the Zoom link first time.
Yes, sir. I have
That
joined.
is for that
I have
is for
joined, sir.
students. That's only for students. For
Sir,
faculty,
I have joined,
it's
sir.
always the Teams link.
Okay, okay, no problem.
Joined.
Yeah, go ahead, Subbareddy.
Sir.
Subbareddy has joined now?
Yes, sir.
Yeah,
Yeah, okay. Okay,
will
Uma
just-
Maheshwari, can we start now?
Yes, sir. Good to go. We can start.
Sir, are you able to see my slide?
Yeah,
yes,
yeah.
sir, very much.
Okay, thank you.
It is not in full screen, but
Yeah, I will make it.
Yeah.
Yeah, I
Yeah.
think it's full screen, sir.
yeah, correct.
Right, sir. Thank you.
Okay.
A very good evening to all of you. My lecture will focus on the usage of artificial intelligence for the smart energy management. So this project was undertaken between the government of India and also the government of UK. This is one of the vertical which we try to implement at IASC. So I thought this doesn't contain much of the programming aspect, doesn't contain much of the artificial intelligence we have been used. Of course, a lot of sensors, lot of information and programming which we have been developed at locally, including the data loggers have been implemented at the campus. So I thought I will share some information, this especially for the non-STEM people, where they could understand better about the use of AI for the energy management. So that's the reason where we try to see and discuss few things. So first of all, let me thank the Edunet team for giving me this opportunity. Thank Professor Jamdagni and my colleague Prabhakar for this time, and also introduce the activity which we have carried out at IASC to the participants. Yeah, I thought I will just put this photograph with Professor Jamdagni and the entire team of Microsoft, LinkedIn, SAP, and other officials who were there during the inaugural of this program, Edunet at Bangalore. About IASC, I do not want to go deeper into the IASC origin of the institute. Many of the times, Professor Jamdagni and many of our colleagues would have mentioned. So I had few slides. I will just roll down this. Some how it started and all. I will just go to the programs. Yes, this is one slide which I just wanted to present to the participants here. We have programs here, regular programs and also online programs. So this we have postdoctoral programs, PhD. Then we have masters in technology research. This for external research program, and also for the QIP faculty working in various colleges, universities, so on and so forth. Course programs, of course, we have MTech. MTech online also we have started through the CCE. And we have masters in management, and BS we have started in almost like a decade back. So we have BS research. This is a 4-year program. In case the candidate would like to continue for 1 more year, it will be a master's in research program for 5 years. And we have also started recently BTech in maths and computing. This is for 4 years. And we will be soon starting the School of Education at our Chalakere campus. This will be on BSc BEd and MSc BEd very soon. So these are a few of the programs which regularly the institute runs. And we do also have some of the programs like short-term visitors program. This is for the children or the students who are working in their degrees. It could be the bachelor's, master's at various universities. The students can come through Indian Academy of Sciences, that is Joint Science Academies, where they have the portal open during October or September, and by Jan the allotments would be done. They have paid the scholarship to come and work at IASC or IITs. So this is one of the program which will be very useful to the students who are working in various other universities apart from IASC. They can come here for about 2 months and interact with the faculty members, look into the topics where in case they are doing the research activity. This could also be for the teachers. Summer research program is not only for the students, it's also for the teachers of various universities. So with this, I thought I will just introduce. These are some of the programs. Many are available on our website, iasc.ac.in. When you go to the academic section, a lot of information is available. Yeah, IASC, we have been here for last 110 years, and the second campus happens to be at Chalakere, near Kudapura, Chitradurga district. This we have been here at from 2011, where we have exclusively teachers training for high school, pre-university, university faculty, and skill development programs for various skill developmental activities. So this is the second campus of IASC, where we conduct a lot of training there. So yes, I do not want to go deeper into IASC. A lot of information is available. We have a total of 6 divisions here. Medical sciences is the new division which has come up. Very soon we will be starting the master's and the PhD programs in this. And interdisciplinary, electrical, electronics, mechanical, physical, biological, and chemical sciences are other divisions which we have at the campus. So several world-class facilities. Of course, we have supercomputer department, nanofab, AFMM center, and BSL-4 accredited labs for research. And of course, vibrant academic environment at IISc with interdisciplinary ecosystem, internationally trained faculty, fully funded programs, and several startups for last a decade or so. We have MSME Center for Excellence, which is also doing a lot of work to MSME development. And several industries have been collaborated with IISc for the technology incubation and business and many activities. So in that way, a lot of activity happens here. I know I will straight away now start my area where apart from this, just wanted to introduce this. So coming back, where do we use artificial intelligence? In case what we have done, this will be for the energy management of the campus. So IISc started in 1909 and we have a 400-acre campus at IISc Bangalore. Many of the times it so happened that each department, 45 departments, we have utilities, we have many of these things, which the power monitoring was not available, and we consume presently around 45 lakh units per month, and we pay somewhere around 4.5 to 4.8 crore for the electricity authorities monthly consumption. So this work which we conducted, myself and my colleague Professor Umanand, who were both in the Indo-UK project. So we tried to think about how the power which we are trying to see how this could be done in a nice way so that we could save some money. We could also see how the monitoring and how imbalances, many of these things could be happening. So with this in mind, it is we started one particular vertical which was funded by the government of UK and the government of India. This was a joint proposal from India and the government of UK. So we had collaborators from University of Loughborough, Warwick University, Imperial College, and a few more universities and industries from the UK side. And we have a few IITs and industries from the Indian side. So this is how it happened. And one of the vertical happened to be the smart energy management, which there was no energy management at the campus before this planning was done. So what we did, yes, of course, I would like to just mention few things because there are non-STEM students who are attending this. Very few information about the use of intelligent transformers. We are in the age of intelligent transformation. And a lot of techniques in the modern intelligence, we use it for various applications. So this could be artificial intelligence, machine learning, or deep learning, or sometimes we also use artificial intelligence versus money. We need to know which is better to use where exactly. So whether we should use AI or ML or we should use for deep learning. So these are few of the things which a beginner or a person who have not much of the background of the AML or the machine learning or deep learning need to understand and try to focus upon. And also the classification of AI. There are again experts here, my colleagues, who will be telling about many of these things. So how the classification of AI is based on the capabilities. So this we will look into that before I actually move on to my topic. And where could this AI be used and how it could be used for applications in research, education, and industry. So very important. Many of the times we need to go with the technology, available technology, and try to use the technology for our requirements. This could be for, as I mentioned, for research, education, and also for the industrial applications. And we are in the era of interdisciplinary research. Or interdisciplinary is becoming a very fast way of adoption. Example, you can take an electric vehicle, simple electric vehicle. So to develop an electric vehicle and to see how the functioning or monitoring or how it could be used. So it is not a single discipline area. So electric vehicle, it is a automobile, it is a mechanical, we have electronics in that, we have a chemical engineering, which is related to the battery. We have battery management system. Again, the information science, computer science come here. So likewise, there are several branches which come together and the understanding of the electric vehicle can be happening. Else it is very difficult for a single domain researcher or a single domain person who works in this. So interdisciplinary research plays a vital role, and how the AI or models of machine learning could be employed for various monitoring, functioning of this development, and also for the industries. So we know that I'll just touch upon few basics facts which we use day to day. We know that in 21st century, when data used to become intelligence, in the past, what happened was whatever data was available, we were informed about the available data. Presently, data is learning from us. So we feed the data, and that is how the data is being given to our models, where it tries to learn from here. Maybe in future, the data will start thinking for us because with the availability of the information. So how does this exactly the transformation does happen when you see the past, present, or future? So when you look into the modern, what we call pillars of modern intelligence. So here, example, machine learning. This machine learning is the learning from the data and the past experience. So past experience, past data models, lot of information, it needs to be available. Then you use various methods. It could be the deep learning, understanding complex patterns through neural networks, many of these things. So likewise, we also been looking into yeah.
Sir, go ahead, sir.
Yeah, for some reason I think it went off.
Oh, okay.
Dr. Reddy, you're off.
By the way, we are not able to hear you, Jamadagni.
I see.
Very
No,
faint.
not completely off. I think.
I can't hear you well.
Yeah, yes, sir. I'm back.
You're back.
Yes, sir.
Back.
Yes.
Loud and
Yes.
clear. Yeah.
Yes, sir. Thank you.
Thank you. Thank you. Right. Bye. I'll leave you.
So, well, its screen is visible, sir.
So, sir, Dr. Reddy, your slides are not visible.
Yeah, I am just connecting, sir. Yes, sir.
Not yet. Not yet.
Right.
Still not.
Yeah, I will connect, sir. Here.
Yeah.
Yes, sir.
Yeah. Now it has come. Yes.
Yes, from current slide. Yes, sir. Sorry for the interruption suddenly. Yes. So, yeah. So some of the use cases when we use it for machine learning. So this could be like a simple consider when you go to a library, basically when we search for something or in the Google. So once we go to the Google and try to search few things, suddenly the user may select one of the first few links and spend some time there. If he is able to get that information, yes, we do not go further into that. In case the information which is available there at the first shot is not comfortable or not, which is required or which is to be useful to the user, then there is a chance where the user goes to the second or third page and try to Google and try to find out. So the Google understands what exactly we require, and this will be one of the way where this machine learning is being done and it is being used. Similarly, when we look into the deep learning is generally when you see any of the typical images. It could be one of the example which I have tried to give here. It could be an old picture of a black and white. Then how this deep learning helps us to make it fully into a different picture where it is much more useful. So this adoption of neural networks, adoption of the deep learning techniques or several models which have been developed. Generally, we mentioned about the convolutional neural networks which are being employed. So here with that algorithm, with that neural network, we could get a fully colored images which could be used for the work which we are trying to look. So simple is that black and white image, how it is being done, and it could be searching through the web or available data to recognize the features or feature extraction of that which are hidden in that. And it could be mapping to a particular color to which an object can be selected. And finally, the selected object could be obtained. So this is a use case scenario for a simple use case scenario for the deep learning techniques. And when we look into the artificial intelligence, so that was about the deep learning and about the machine learning aspect. In case of the artificial intelligence, here again, many of us use the Alexa or many of these voice services. So these voice services, when a user tries to use this, get the information and how this voice is converted to commands and how it is being processed and how the voice output happens. So these are all some of the services which you could try and see. We are able to get this and which are being obtained for last several years. So this is a simple way of an artificial intelligence which is being done to make the life simple, and also it could be like simple finding out the Google Maps and trying to get the information, which was a very difficult earlier days, where we are able to see with this available information and very easy way of getting the things done. So this is one of the way where an artificial intelligence works. Now coming back, how machine learning, deep learning and artificial, which is better, which is when to choose and how to choose, what to choose, whether depending upon the problem, depending upon the requirement, depending upon the research which you are trying to focus or a study which you are trying to focus. So which is to be try to be adopted for a particular area. So this needs to be planned and this needs to be see what was the problem which need to be tackled. So based on that, we can choose whether we need to go for artificial intelligence or a machine learning or a deep learning, or it could be like a simple, if it is a basic concept of AI, what is that, like machine learning? Machine learning could be a basic approach to create artificial intelligence. Similarly, people talk about computer vision. Computer vision is just by you, it is could be achieved by again going in or using the deep learning models. So machine learning versus artificial intelligence or deep learning or AI and machine learning and deep learning. So this particular information, when you are trying to see what is the problem which you are trying to address. So based on that, any of these models can be chosen for the work. So simple case is example, when you go to a library, you need to there are a lot of books which are there and you need to find out few of the books which you need to select. Now there are various ways how this AI or deep learning is being used for the selection of the library books, AI with ML and deep learning also. So a simple artificial intelligence where you try to locate the book or you try to get the book, this could be done with the help of many of the robots or wherever information, like a simple, you would require a particular book. So when this command is passed on, there is an information which has been circulated and it tries to locate with the help of a deep learning models. So the book could be located and further from the digital data, the data is analyzed and the text using the machine learning is tagged on, and finally the book is located, and this again using a robot or with the help of the robotic arm, these books could be identified. So here we have a deep learning models which are used. We also have AI which is being implemented and see that the exact book is located with the information which is being done. So here again, AI with ML and deep. This is just a Venn diagram where it gives the information about how the deep learning or a machine learning or artificial intelligence machine, how the deep learning, here generally the machine thinks like a human being, where it uses artificial neural networks and try to locate the requirement which you have made. Similarly, in machine learning, what happens, systems learn things without being programmed. And AI, yes, of course, AI is just intelligent machines that think and act like almost like human beings. So in that way, all these three are important, and how we use it is also important. So here I am just giving information where AI with ML and deep learning. This is a simple example of Rediff news. When you go, a lot of this information is available, and the reader of this news many times would have come across, or you would have seen when you click on the live of the Rediff news TV, you hear these people as an anchors giving the reading the news. So in fact, these anchors or these people who are reading the news are not the actual humans. So they are basically trained AI people. This is AI generated images where these are being read to us in like a simple, like a normal human being. So where the technology has been adopted in such a way, it is almost like human beings coming and informing the news, or this have been developed, and we are presently being seeing not only in Rediff, many of the AI generated images we are able to see. So this artificial intelligence again depends on the capabilities, and it is classified based on capabilities. Typically, some of the types of artificial intelligence which could depend on the capability is, again, it depends on what type of information do you require, what is the memory limitation, what is the reactive machines, whether the system that only reacts, whether it has some memory content, whether it has some past experiences information or the new decision. So several of these applications, like we are presently being using as a spam filter, email sorting of systems, basic, as I mentioned, Alexa or a Siri, which we use it for our help in locating some of the areas or some of the destinations. Then facial recognitions. Again, facial recognition, you have a thumb impression similar to a facial recognition. It could be at the entry of your offices or at the mobile phone or facial recognition. Several of these things are also being depending upon the capabilities where AI is being employed. So again, there are various applications. It could be knowing self-driving cars or chat GPTs, which we are presently being using. Many of the children and many of the faculty or many of the people start using this. Yes, we need to be a bit careful when we are using. There could be the information which is immediately available, but the information need to be verified, and then we need to adopt that information. So likewise, various applications, it could be recommendation systems for customer support, or it could be for the fraud detection systems. It could be for speech recognitions like Google Assistant, Alexa, Siri, and many of these things. So here, basically, again, it depends on the various aspects. On the limited memory, then systems looks into the past, information may be added over a period of time. Then information is sometimes short-lived depending upon the availability of the memory. So then theory of mind. So it could be limited memory, then theory of mind, and self-awareness. So these applications, it could be like many of the time we have MIT Media Labs, we have Sophia, Replica, emotion sensing cars, which are used in Toyota concept, and chatbots and so on and so forth. This is again systems being able to understand the human emotions and how they affect the decision making, and to adjust their behavior according to the human understanding. So these are some of the typical artificial intelligence based capabilities which we find. The other is the self-awareness. So reactive machines, we have looked into the theory of mind and self. Here the applications could be, and again, many, this could be from various applications and the systems being aware of themselves, try to understand their own internal states, predict other people's feeling, and also act appropriately. So likewise, AI has being different types based on the capabilities. And now looking at AI and adoption in research, education, and industry. So how can we adopt the applications in research, education, industry? Few slides here. So we have seen now in the research, we have optimization problems. We encounter data analysis and pattern recognition many of the times here. So in case of optimization, there are desired parameters which needs to tune, control system refinement algorithms which we use. And in data analysis and pattern recognition, yes, automating insight, extraction, information extraction, data analysis, interpretation. So several of these areas do adopt AI and try to use for the better presentation and also more efficiently and try to see it in a more accurate way. And many of the times we also researchers try to use it for literature review automation. So try to get, instead of other days where you could use the simple textbooks, go on, used to take lots of time. Now the students do not go to the library at all. With the literature is being completely automated and where you are able to get a lot of information uh, where the AI and other models are available. It just summarizes and gives the information about any of the keyword, any of the research activity which you would like to read, which you would like to get summarized. So this type of models, this type of information is available, and a lot of research activity researchers are using for their activity. This could be in terms of like commercially available Litmaps, Elixir, MathWorks, Optima. Several of these things are available commercially, where you can use it for better interpretation of your problems and use it. Coming to the education, here again, AI is being used in a lot of content generation. This could be automated. Like many times we see the quiz, notes, multimedia creations, and question paper creations. It has made simple when hundreds or thousands of children or participants are taking up subjects. It could be like a move
Hello, sir.
Dr. Reddy, there is an interruption again.
Yes, we lost you, sir. Yes. The sir is rejoining, so we'll wait for a minute. Okay.
I contacted Dr. Reddy. His computer has gone into one of those moody phases. So he is rebooting. It takes a little time. I think as soon as he reboots, he will join. Sorry for the interruption. I don't know where he is speaking from. Probably some problem with the power supply or something, or the network. It shows that we are really not completely free of glitches in the modern technology. Yeah? We still have problems. Things don't work. And then invariably, the Murphy's law always works. When something can go wrong, it will always go wrong. I hope he will join very soon. I'm just following up. Maheshwari, do you have his email or his number?
No, sir, I have an email ID. Let me also.
Yeah, no, just to, in case you want to contact him or so,
Okay.
then you can do it through email. So you don't have any.
I have an email ID of Subha, sir. Subha Reddy, sir. Yeah. I'll send a message.
Okay. So I hope, I mean, I just now contacted him. He said that he's rebooting, and that's it.
Okay, sir. I think we can wait for 1 or 2 minutes. No problem.
Yeah, no, I mean, you're going to
Faculty
you have to
solution.
wait for whatever time it takes for him to come back.
Yes.
Yeah. Okay. So I'll be online. Let me know what happens, and then let's see.
Okay. Faculty members, sir is trying to rejoin, so kindly be.
Yeah, I announced to everyone saying that he's trying to reboot.
Yeah,
So
yes.
he suddenly went into some funny phase, and it is he's rebooting, and he will be back as soon as he can. It's a technology problem.
Okay.
Sir, can I ask a question in the meanwhile?
What did you say? I didn't hear it properly.
Sir, can I ask a question in meanwhile?
Yeah.
Sir, I was just thinking that we cannot rely on AI totally, but it is useful for big data sets, big data set analysis. So is there anything to calculate error if there is an error by any chance
Say that
in
again.
analyzing a big?
Wait a minute.
Yeah.
Go slow. And I didn't hear you properly at all. What are the questions?
The question is, AI is not totally reliable. We can take help of it, but it can be useful in big data set. Right?
Well, big or small data set is not the question. Small data set is the one
So
which, as Dr.
that's
Subbarati
first part of
indicated
my question.
today, we are using it to learn. So that whether it is large or small, we don't know, because small data set in present day world doesn't work at all. I mean, they use a large data set. The problem is not that. The very mechanism of learning and the very mechanism of AI actually has certain inherent built-in unreliability, which we used to call it hallucination. Now it is slightly better, but still it sort of can give wrong answers. So it has nothing to do with the data set or anything. It has something to do with the very nature by which the whole system operates. Therefore, irrespective of whether it is large data, small data, whatever, you have to be very vigilant about it. That is the problem.
So my question, so I get it that. My question is, do we have anything within AI which would let us know what is the error if there is an error?
Oh, no. There is nothing like it right now. The thing is, I mean, it comes back to a little bit philosophically, things like this. If I ask any of us ourselves, if you tell me, can you think of what you did wrong? Do we admit it? No, it is actually psychological. But in the case of machine, it has already learned based on certain data. So that fellow a priori did not know whether the data is right or wrong or proper or improper. So there is no way AI can even tell you that it has done something which is wrong. When it keeps learning more and more and more, maybe over years it may come to such conclusions. But at the moment, when I have used it for actually learning it, that is, I have used it for training, the fellow doesn't know whether it is right or wrong. Whatever we have given, it assumes is the data that it has. Suppose you keep on training a machine, giving pictures of dogs and calling it cat, there is no way the machine can tell you that the fellow is learning about cat or dog. I mean, that is the data that you have given. You have shown pictures of dog, but every time called it a cat. Then you cannot blame MI because the way the machine learning is learned is based on what you have given. Therefore, to come back and when I show you a dog and it says it is cat, the fellow does not even know that the fellow is making a mistake. That is the problem. You see the difficulty? We are using a large amount of data for training, and therefore the machine learning, as we call it, which is the basis for artificial intelligence, will actually learn based on what data we have given. In case the data that we have given is either a wrong data or ambiguous data or misleading data, there is no way so my machine learning is going to tell you that you have given me wrong data. Suppose you keep on giving pictures of aeroplane and call it train, the fellow will think that it is train. That is where the human intelligence.
Sir, I have another example. Sir, I have another example. Can we take example of climate change? Now, earlier the data was very different. Now we are releasing every day new phenomena. So how would that work if there is to be using AI?
The question again is how you trained it. Suppose you
Sir,
have,
if
if
we
you see
use
what you
AI
are
for
doing,
climate change,
yeah, about climate change, what you are saying, what you are training is that every time you are giving a new data, let's say this year, the temperatures have been high everywhere. Suppose while training, I say that this higher temperature is because of climate change, the fellow will detect it. Suppose we say, no, nothing wrong. Temperature increase is because of normal things that are happening on Earth. How will that fellow know that it is a climate change? It depends very much on the training that you are doing. And suppose a skeptic of climate change trains the machine on whatever data you have. How will the fellow know that there is a climate change? So you have to go into a little bit of keep thinking about this. After all, the learning is completely based on what data we give and how we train the fellow. If we train the whole thing wrongly, or don't want to call it wrongly, suppose we train this fellow with a bias, that bias will be carried. Isn't the same about us? You see, you should, if you take another extreme, other end of an example, look at very young children, 2 to 3 years. They learn any language so well with all the proper accents and everything that has been done. And a child at 2 years of age will learn French or English or Kannada or any other language as a total native will learn. Give it time. Over a period of time, we cannot speak the French speak. So everything that we talk about in artificial intelligence or in this one, it is based on training. You are expecting the system to have an independent intelligence, which will come and say there is a climate change. Where will that intelligence come from? Where will it come from? It will at most draw a graph saying that temperature is increasing. But how does that fellow know that this is what it is? So I think there is a fundamental issue here. The issue in the sense, a feature that any artificial intelligence system with machine learning is given a lot of data, and the data actually trains the whole system into a model. If there is a fundamental misunderstanding at the level of data and its interpretation, there is nothing that you can do. You see the problem?
Sir, I think Subha Reddy sir joined the session.
Oh, he has joined? Okay, sir,
Yeah.
Dr. Reddy, go on, sir. They were asking some questions, so I was answering them. Not in your area, some general questions.
Sorry, sir. Unable to. It's very, very slow.
What is happening?
Suddenly it went into, it hanged, sir. Then again it went to I don't know
Is
the
it on
reason.
now?
I will just put it, sir. Share. You're able to see, sir? No.
No, not yet.
Trying to share. Share. It's taking some time. I don't know.
Yeah,
It was suddenly it switched off, sir. I don't know. Maybe some limitation in the institute side or number of, I don't know.
Power glitch maybe.
Yes, sir. Now I am trying to share. It's telling it is loading. I don't know. It says.
Sometimes it works if you say stop sharing and share again.
Yes, sir. I will do that. Copy link. Share. Share.
Stop sharing, share again.
Yes, sir. Unable to share. Yeah.
Unable to
Share.
share.
Yeah, share. Now, sir, I'm able to. Yes. It's showing, sir.
Your screen seems to be coming up because I see your name on the screen. SB.
Yeah, I'm trying to share the share copy link to slide. That is.
Uma, can you guide him?
Yes, sure, sir.
I'm trying to share here. Share after that.
So Uma will try to share. I mean, will help you. Hopefully, things will happen.
Link to the slide. Copy link. Get PowerPoint. Share.
Sir, better you can share it in the mail so that I can take it from my end. Is that okay?
Yeah. That is also possible.
I don't know. It's a big slide. Yeah, I will. Yes.
So you can share it in the chat as well. We will be looking at, you can see your own slides and we will be seeing our own slides.
No, somehow when I'm going in for share, it is simply telling it is loading. There is one which says now send AI presentation message copy link. Send, it says send a copy. I don't know why it's going there.
Sometimes it is due to the space issue also.
Yeah, maybe. Maybe I don't know. This could be
multiple tabs may be opened. That would also be the reason. That is fine, sir. If you share, yeah, we can see your screen. Yeah.
Now you're able to see the screen. I will share now.
Okay.
Share content window. Yeah, it does. I think it should come now.
Yeah, your name has appeared.
Yes, sir. I think.
Working, I guess, sir. You can go to the slide. We can see.
It's coming.
Yes.
Yeah, it has come now.
Perfect.
A slide show from customer. I don't know. Yes, sir. So I was looking here. Now industry, yes.
Yeah, it is not in full screen, but
yeah, it's full screen, sir. Now.
No, not yet. Yeah, now it is.
Yes, sir. So research I was mentioning, then education, of course, lot of tools are being developed for the content generation. Now we also use for plagiarism or.
Dr. Reddy, if you
yes,
want some of these screens, I mean, some of these, as because of time, you can skip because we have covered some of them in our
lecture. So what I will do straight away, I go about
directly electricity.
Yeah, I'll be going to my topic here straight away.
Microgrid schematic level. From here we can.
Yes. So what we have done using this AI and the models which we have developed. So we have considered IAC as a microgrid. This is the schematic of the entire IAC microgrid, what we call. So we have a 66 kV bar 11 kV substation, which is incoming, and we have subsequently there are 25 substations. These entire power the accommodations. We have departments, we have utilities, many of these things. Of course, we use the diesel generators. We also use various battery backup in case of supercomputer department. We have also installed several of the solar panels on various rooftops of the institute. So our intention was to see that how this facility, our energy management system could be implemented in the institute. This is where the energy management, as I mentioned, it is an interdisciplinary area which required a lot of concepts from various fields to make the system to function. So here the new monitoring and control mechanisms were required for proper planning of electricity generation and distribution, so which we have done here. So the solar PV which we have installed on various rooftops. Then we also have a small thermal solar facility, and we have a lot of things to be properly managed. That is, the load management need to be done, and real-time monitoring and control is very, very important for the institute. This is where we thought, and our objectives were very clear. We wanted to build a multi-model system towards saving energy and cost, which I was mentioning, some 45 lakh units, and we pay around 4.5 to 4.6 crores per annum. So, and also our intention was to reduce the carbon footprint, both at personal and community level. And we need to we had to obtain information by developing various intelligence sensors, looking into the models which could use various methods for energy harvesting. And also energy network, which I mentioned was 66 kV bar 11 with 25 substations. We had to have a recursive architecture, help in proper balancing demand and response. So we had to make decisions which were made to be with distributed processing in real time. That is very, very important. The information which we wanted is every minute by minute data information of all the entire institute. So here, this is just the planning, power and communication network, which it gives. We have established a video wall dashboard at the Department of Interdisciplinary Center. Through the source, you can see the red is the power flow from the master unit substation 66 to various SS1 to SS25 different substations. So this available information, how do we do that? So we have planned in such a way the information which is shown here. Information flow is also indicated here from the main substation to 25 substations, from the 25 substations to various departments, utilities, and to the video wall where dashboard is available. So here we have placed the sensors, smart meters, and the data loggers to get the information. And we have tried to develop the models which could be useful for our electrical network. So that is very important. So what we have done, as I mentioned, we considered IAC as a microgrid. Here, electrical energy requirement was somewhere around 8 megawatts is a requirement at the IAC regularly. So we wanted to see that IAC should go green by offloading some of them. This is where the solar PV establishment happens. So for this, we had to do a lot of work. It could be audit of the rooftop available, and many of the department-wise energy audit we tried to do. We have done life cycle costing analysis, and coming back, use the smart meters, data loggers, and many of the models which we have developed. So this is a typical way where we try to estimate the rooftop solar of the available places where we could install the solar power. So we try to estimate, and we try to develop some models for this. Here we could generate around 7.6 megawatts, which our requirement was somewhere around 8 megawatts. So depending upon the money which we were received, we started planning to install solar installations at various locations. This is the design specifications and installation. I will not go deeper into that. We try to develop a small model and try to see how economically things will work out, and considering all the parameters, we try to size the PV, we try to find the life cycle costing of this, and with the available results. So we were able to see what type of panels, what type of specifications, what type of insulation required. So we tried to proceed, and we started installing at various locations. And we need to connect the DG sets available, which is presently around 8 megawatts. We had to do hybridization with the renewable energy planning, that is solar, and also future we could go in for some other, not only the diesel. So this is how the connectivity happened, master substation. We have told 25 substations from their departments, utilities, many of these things. So we estimated 7.5 megawatt. This could be generated. And this is how we started installing at various locations on the departments. So these are few diesel generators integrated to the main solar, then battery backup, all these things along with the raw power, we had to do this job. So we had to use the smart meter for this energy management. What does the smart meter? Basically, it measures power, measures energy. It is typically different from the normal meter, which we used earlier, analog type of meter, where energy in kilowatt hour and the voltage and current used to have. But here, this smart metering helps us to precisely inform about the phase and line voltages, phase and line currents, power factor. So many of these terms for our students maybe heard earlier or not heard, but these are various parameters which we had to look. Phase imbalance, very, very important. Without proper balancing, the activity is not right. So we had to look several of these things. Peak demands, power down periods, harmonic distortions, which could create a lot of problems for the research and also the departmental networks. So we tried to develop several of these things using various models, and we came up with issues which were also like information pertaining to the monthly or a weekly information where we could get from this. We started also looking into the peak demands wherever the department requires. Based on that, we could divert the power. Similarly, fault alerts, complaint, then the basic smart energy management was typically generally consists a simple entry point near the distribution of the department or distribution at the substation. We have CTs. Here is a smart meter which we connect between the CT, and in case of HT, we connect it to the PT. That is a potential transfer. But then we have a data logger which was developed where that entire information for each of the data logger, 4 devices, more smart meters could be connected. And this is connected from the smart meter through a Modbus. And for this, we had to power. So we have a SMPS which powers the data logger in case of the power disruption. So this information which is stored in the data logger had to be collected in a server. So again, collection of data is very, very important. Either it could be done through a LAN or a Wi-Fi, and wherever difficulty, we also used a modem or what is using a dongles. So this information was collected, stored in a server, which is very, very important minute by minute, or sometimes it could also have in seconds data is very important to analyze whether a fault happens. Then we had various application softwares which we tried to develop. And this application softwares has generally 3 layers where as I mentioned, the data acquisition happened. Then the analysis. What type of analysis? So for data acquisition, we use smart meters, which were mounted at major entry points in the campus. We had data loggers to read the registers of smart meter and transmit the data. And the server was used for pre-processing, storing of the data sequentially in a database. And we tried to do a lot of analysis. This is both supervised analysis to look into any deviations from the rule or any issues related to alert. And unsupervised also to model the system and detect deviation if there are any things to be predicted. So applications involved several. It could be fault detection, diagnosis, distribution of network status, billing management. Earlier, we had only 1 meter where we used to see the billing and the power consumption for the entire campus. Now we have developed models where each of the department is being alerted about the consumption of power, what could be the typically of each floor of the department, like example. So monthly energy consumption, proper planning, reporting, and many of these things were implemented based on the personalized role of the activity which we were planned. These are few of the samples which we had developed. So it could be active power for the various periods of the year. It could be the apparent power profile. It could be the energy consumption total. It could be the reactive power. And wherever we have tried to put up the solar, how the solar is being injected into the local grid, how the consumption has been decreased, and monthly power factor. Power factor is very important. We need to improve upon the power factor, how is done. So since 2020, we have started looking into that. And for the last 6 years, we have been collecting the data for all the renewable parameters, including the diesel generator. We have integrated all these things together. And yes, we have developed a competency of the monitoring systems from local importing the energy from various nodes. Nodes in the sense each department. There may be several nodes, like from the departments, from the sections, from the utilities. So we have developed a monitoring system where entire information is available on the video wall or through the sensors which we have placed at different location of the campus, all 45 departments, utilities, and so on. And we get the trends or the information in case there are failures, in case there are issues, in case there are outages. So several of these things would be analyzed, used for our research activity. And also this has been also adopted in few of the IITs and many of the industries after we developed. And we were also requested to being invited in at MIT to deliver a talk on how we try to implement in a very, very simple and novel way using a simple methods. So in that way, yes, we had a lot of information. We tried to gain a lot of expertise in that. We also tried to use this technology, and we have also implemented in our Chalakere campus, trying to integrate various renewable sources that is being done. And it gives very, very important information for future planning, future activity, how the load balancing has to be done, how the power factor improvement, harmonic related issues which crop up, very, very important. So many of these things have been developed. And we also used to face few of the issues during the installations. Yes, of course, it is a learning exercise. We have tried to overcome many of these things, and we have been successfully implemented this. And as our primary objective, we have tried to reduce the energy and cost. A lot of savings towards the billing of the cost for the institute, and we have tried to implement the aspects like solar, building integrated PV, diesel generators, everything to get. And as I mentioned, we have been using various developed models and implemented for the entire campus and also the Chalakere campus here. Further to that, again, research activity, we have tried to see that various combinations along with our colleagues from the UK government. We have developed a lot of models, and data sharing is happening. And of course, many of the IEEE transactions we have come across, this information is also available. And we have developed also towards demand side energy management. This was very important. Here we tried to develop non-intrusive load monitoring techniques. And we have also developed a prototype of the IoT-based energy management systems in collaboration with the Lauper and Warwick University. We have developed the mobile apps for the control. This is very, very important. So here we can control various loads. We try to get the signatures of various loads. It could be fan, it could be AC, it could be heater, it could be fridge, many of these things. So through this, we have been also developing several non-intrusive load monitoring. Students are working for last 4 or 5 years in this. This is a typical prototype where the control could be done using and also for energy disaggregation studies. We have been using various energy demand models, which based on IoT. And of course, a lot of these things are also published in various IEEE transactions. And as I mentioned, we have the signature profiles of various units which are consumption. Now we would like to inform and tell that when exactly the optimal usage of power could be done. It could be at household purposes or at the industry or at the research institutes. So these have been continuously being done by our master students and also the research students, and being presented at various forums on the demand response with again looking into the anomaly detection, load scheduling aspects. So several. So these are few of the things which again very recent one of the IEEE transaction we tried to present about the intelligent air conditioning system, usage of that with solar PV and load monitoring techniques. So these are all not only the theoretical developments, also parallelly looking into the hardware part, trying to develop present the facts. Yes, this was one of the facility which we developed at the Interdisciplinary Center for Energy Research. Some other applications using AI for defense purpose, we have tried to develop here using a simple Peltier-based modules where the at the border, the outpost, where the soldiers could be more comfortable in extreme climate. So we have tried to develop, if it is an extreme climate, bringing out a temperature. If it is a low temperature, we can increase the temperature using simple Peltier, what we call as a bricks. So this will has been also being used in many of the applications uh, presently, and students are also working in this area. We have also used this AI techniques and also the hardware development for the hybrid desalination development of desalination facility. This is also being done. Yes, those are the few things which we have employed. And of course, as I mentioned, I'm not an expert in AI, ML or deep learning. We try to use the machine learning models or to a certain extent deep learning models for our related work. And we try to implement this for our present requirement and also for the students who are working here. With this, sorry disruption because 2 times in between. Sorry, sir. I am open for questions. Thank you.
That's okay. So are there some questions we want to discuss? A little more technical talk. So some of you may have some questions to ask. And it can be any question, I mean, related to economy, electricity, grid, and whatever.
Sorry, sir, if I got it wrong or I didn't understand. When sir used smart metering, what is exactly the metering doing in a smart way? Like you said, you are integrating the various power coming from various, and then load balancing is what being done efficiently so that there is no leakages and you're using the power correctly. So we just want to know when you say smart metering, how is it becoming smart now with the metering? Sorry if I missed it out or I couldn't get it.
No. I mean, that's fine.
It's a perfect question. There is nothing wrong in asking questions. Yes, generally earlier we had an analog type of meter when 1 or 2 or 3 parameters. Generally used to have voltage, current, and the wattage. So, or kilowatt hour, where the person used to come, read number of units, and give you the billing and go. So that was for the domestic purpose. Yes, even today it doesn't have any problems. You simply pay the bill. The Bescom or the people who supply you the energy will be giving you the bill. Now coming back to the smart meter, as I mentioned, it has several features, not only those 3 components. Apart from that, it gives the information about the power factor. It gives information about the imbalances. Like example, simple way, at your home, you have single phase and 3 phase. Single phase is just for lighting. 3 phase sometimes you use for your geyser, you use for your fridge, or you use for some of your mixie or micro oven like that. So what happens? At a home, says typically you have a 5 kilowatt load in generally when you're staying in apartments. So if you exceed, then you'll be put a penalty and you cannot also run the equipment below the power factor specified by the government. And for the research, not only the power factor, the harmonics which are generated because of various loads, it could be the inductive loads, it could be very of these things cause the problems for the research activity. We need to have example, a pure sinusoidal waveform for our research activity. This will not happen. So here, one is the unbalance which we create because of the load. And as I mentioned, if it is a 3 phase, at home, we do not know whether we are connecting the loads equally for all 3 phases or one particular phase. If you are connecting to one particular phase, then that phase will be overloaded. Other 2 phases are completely not loaded equally. So you cannot say exactly 100%, 33.33. It will not be possible. But still, there should be a loading equally where you will be able to save a lot of the money. You will also be able to see that load balancing will also help in proper insulation. Why? Suppose if you are overloading one of the phase, the insulation would over a period of time try to heat up and try to give away. That is where we see many of the short circuit and many of these things. And harmonics. So all these are smart parameters which an electrical engineer would like to know: active power, reactive power, which we would not have come across. So these are very essential to see that how we could refine, how could we use it for the electrical research, and also which could not disturb the power electronic devices which we are using abundantly in research or in any of this activity. So the smart metering will help us to locate, identify all these parameters. So we try to use the data loggers. We have developed a lot of AI-based models for this to obtain these things. Generally from electricity, when you put a meter, you don't get all this information.
Sir, Dr. Reddy, there is a question.
Yes.
You said earlier, I believe you said our bill was about 8 to 9 crores earlier.
Yes.
What is the bill now is what she is asking.
Yeah, so the one way, yes, I can say there was substantial reduction of 15 to 20%, but parallelly, number of departments are also coming up recently. So that is where exact numbers, it is very difficult because power is also being added. Lot of medical schools, lot of UG, lot of hostels are also being parallelly connected. So if I tell yes, when our model, when we have put like example, Chalakere campus, we have almost like 20 to 25% reduction in the cost, which was earlier some 5 lakh rupees we used to get. Right now it is below 3 lakhs or so, more than that. So there I can tell. Yeah, here it is slightly difficult for me to tell.
It is. Actually, what we can say is we have not increased the input, but
Yes,
we are
sir.
catering to more departments.
Yes, exactly, sir.
That is about 25% better.
Yes,
So
yes,
that's what. Actually, may I add one small thing here? Actually, what is happening is you asked about smartness. Now these meters can be read remotely.
yes,
Nobody
sir.
needs to come there, and then nobody can actually cheat giving a wrong number or anything. It can be read remotely, and you get all your bills and other things either by email or by WhatsApp or whatever.
Yes.
That's one big advantage
Yes, sir.
that you have in smart meters.
Yes,
So,
sir.
I mean, it is an answer to somebody who asked what is smart. And
Yes, sir.
there are many others. And I don't know if some of you noticed, there are some electricity boards, they were trying to use a prepaid
Yes, sir.
metering.
Prepaid metering.
Yeah, like prepaid phone calls, there was prepaid metering. That is also becoming possible with the smart meters. It is not everyone has adopted it, but it is happening. Okay, any other question?
Yes, sir. Good evening, sir.
Yeah.
So could you elaborate what is the theory of mind and what are the applications which are there using this, and do they have any negative implications?
Theory of what?
Theory of mind. There was a slide which
Okay.
was showing.
No, we will
Yes.
take it up in the next lecture that I'm going to give next week. Today is all
Okay.
about Dr. Subbareddy and his topic. So we will concentrate
Okay.
on that. And then anything which is pertaining to this, because we are going to talk about ethics in AI and other things. So at that time, you can remind me again. We'll come back.
Okay, sir.
Yeah. I may not remember. Either ask Uma to remember or you raise a question again when
Sure, sir.
we start talking about the last two topics
Okay.
next week. We will deal with that.
Okay, okay, sir.
Yeah. Any other question that you're talking about that you're?
Hello. Yes, good evening, sir.
Yeah.
Sir, this is in a very general sense, like since this is a very great solution for power, what
Yeah.
future do we envision for pan-India expansion of this across campuses at least?
Yeah, I mentioned that after we tried to implement a couple of IITs and a few of the other institutes have also been implementing this. And yes, there is a SCADA smart grid which is being implemented at the national level, but this is at the local and the institute level where the quality power and also trying to reduce the billing and try to optimize the power wherever required. This is very helpful for not only the institutes and the organizations also.
Is it Namrata who asked, Dr. Namrata?
Not a doctor yet, sir, but yes, it is Namrata.
Yeah, it's okay. You see, to answer your question, there is a little funny problem here. Many of the new technologies have a lot of political angle before it can be adopted. So technology very often is only about 10 to 20% of the whole problem. I don't know if you recall, about 20 years back, in electricity it was proposed that you have two types of lines. One line is for a single phase, which comes to every home and then will be used only for lighting, and it shall be 24/7. And there will be a three phase, which can be used for multiple purposes, as Dr. Subbareddy said, and that could be for a limited time. And this proposal is there for last 25 years. It was for the first time implemented about 20 years back in one state, and only now you slowly start happening. The technology exists. Everything is known about it. But the political will to sort of do it and the amount of investment that you have to make, very often that is the problem. So to answer your question, whatever Dr. Subbareddy said can simply be adopted at the national level. No problem. That can happen. But that requires an investment from the government. It requires a willingness from the government, and it requires a lot of different things to happen. In a totally different area, railway reservations earlier. some of you are too young to have noticed it. You would go to a station and stand in a queue and book, and it was a half a day job. Then the government proposed long time back to make it automatic. It took almost 15 to 20 years before it was realized for automated booking by railways. So the point is, technology is available, technology is proven, it can spread, it can go everywhere. But for that to happen, there are investments required, and there are political will that is required, and that takes a long time for it to happen. Not only in India, everywhere. It happens everywhere, but it's. Does it answer your question?
Yes, yes, thank you, sir. Like nothing can be considered apolitical in nature, let alone technology and innovation.
Yeah. You see, there is a simple thing like, in Western world, it was there for the last 20 years. When you generate electricity yourself, let's say by having a solar panel at your home, actually many of the Western technologies, particularly Switzerland developed a model where when you have excess energy, you pump it to the grid. And when you take from the grid, you are charged. Then the meter became bidirectional. So when you pump, you are given money. And when you are taking money, then you are charged. But this never happened in our place for a very, very long time. Only now, slowly, some people are adopting that. Some electricity boards are trying. And Dr. Subbareddy knows it too well. He has already done this bidirectional meter a long time back. Isn't it, Dr. Reddy?
Yes, sir. Yes, sir. Yes, sir.
Yeah, you made a bidirectional meter a long time back. It is taking time to adopt. So the question should be more addressed to, let's say, policymakers. Am I right, Dr. Reddy?
Yes, sir. Yes, sir. Yes, sir. You're right, sir.
Yeah. Any other question?
Sir, any project has certain limitations. What are the limitations of this project?
Yeah, limitations, of course, when you want to expand in a larger way, initially investment is one thing. Second is, yes, you need to have some good people to do the job. Yes, you may have several ideas, but implementing, you need to have and have patience. Many of the times things run out from where there will be difficulty in locating the issues. Also, there will be sometimes the data monitoring. Suddenly, you have to monitor from a far off place where LAN and Wi-Fi could not be reachable there. You have to use some dongle or some modems. Yeah, there are some issues which you can overcome. Just because of some issues, you cannot stop to see and get the things done. There will be few things initially. Later on, you come over those issues.
Actually, it is a credit to Dr. Subbareddy and the group that they have implemented this in a very rural area in Karnataka, where when they went initially, they even had a problem with connectivity, problem with electrical power, and so on. And they have been able to slowly overcome that and implement. So what Dr. Reddy is saying is this has to happen at the national level. Am I right, sir?
Yes, sir. Yes, sir. Yes, sir. As you told that at a rural area, which is very, very far, when we integrated the solar, we had some issues. I'm not telling that we didn't have, but we can overcome. It is a learning for us. And when you implement any practical project, there could be some hurdles. We need to cross that. It will not be very difficult.
Yeah. Okay. Dr. Rama says, congratulations to you, sir.
So
and
thank you,
many others have also joined them, and they appreciate your efforts.
Thank you, sir. Hope it has been useful, because sorry for the interruption in between.
The main highlight was you were showing this in a very technical area, which is actually very domestic, if I may say so.
Yes,
very
sir.
domestic
Yes,
problem.
Yes,
so
sir.
that's a very interesting thing. So it says AI can enter homes at all,
Yes, sir.
At all levels.
Yes, sir.
Now,
Yes,
like
sir.
internet has come to us at
Correct,
home, AI is going to enter homes very soon. And you have shown that this can happen in a campus. It will happen
Yes, sir.
to other homes also in future.
That was the intention to.
Yeah. If there are no questions, then we will thank Dr. Reddy for his talk, and then we'll close the this one. Dr. Uma
Yes.
Maheshwari, is there anything that you want to?
Yes, sir. Yes, sir. Yes. So I there is no question, then we'll close the session. Before that, sir, Subbareddy sir, we really got a lot of various idea about this, electric meters with a valuable, real-time examples, and supported by, it's really a practical real-time example which we see on the screen, like different pictures which is presented. And thank you so much for joining today, sir. It's
Thank you.
yeah,
One other
great.
thing which many participants might have not noticed, Dr. Subbareddy is one of the prime supporters of the AICW program from the institute side. He actually leads that group in Chalakere, and he's one of the big promoters, and hopefully we will see him more, and you will come to Chalakere maybe, or to Karna Indian Institute of Science or whatever, and then actually the whole program is moving because of his initiative and Dr. Prabhakar's initiative from the institute side. They work with all the administration and make it happen. So thanks again to him for making this happen.
Thank you, sir. Thank you. It is not only one or two persons. Of course, you are the behind of entire this activity. Institute has been collaborating with Edunet and many of the other organizations.
But you have sort of negotiated all the MOUs, and so that's good.
So we will also be very happy to see participants on one of the day during valedictory or so. We will try to host them. So you can come to IAC. Yes, sir.
Yeah.
So thank you all for joining and patience listening. Thank you all.
Thank you,
Thank
sir.
you,
We
sir.
are delighted to
Thank
be
you,
here
sir.
and part of the session. Thank you. Thank you so much.
Thank you.
Thank you so much, sir.
Thank you, ma'am. Thank you. Thank you.
Thank you, sir.
Thank you, sir. Thank you so much.
Thank you. Thank you.
I think
Please fill out the checkout form and we can leave the session. Thank you so much for joining. I hope you all have the checkout form. Rama ma'am, Chandni ma'am. Chandni ma'am,
no,
I
ma'am.
saw your PDF document already, but I'm sorry. Today I'm a little busy with this, office work, so I'm not able to see it. I will
No
reply you.
worries.
Okay.
No worries, ma'am. No worries. Maybe if you are free tomorrow, we can connect.
Yes, sure.
You have shared the
Sharing.
checkout form. Are we not able to see, or can we go to the dashboard and then?
Ma'am, it's there in the website only, no, Uma ma'am,
Yeah.
or how is it?
The teams, they have pinned the message already. 1 second, ma'am. I'll reshare it. Can you give me 1 minute?
Sure.
Yes, ma'am. I shared the checkout form. And one more thing, please try to start with this report, PPT, and the project implementation, so that we can see some implementation part on maybe on Monday. Possible because we have 2 days of leave. I know there will be a lot of work for us, but Still, we need to complete this, ma'am, because we have only hardly 2 weeks to go. So whatever the input we give for these 2 weeks, that